All right, welcome to Blast Furnace. This is the first Blast Furnace we've had back in at Dashworks since the COVID restrictions have been eased. So I'll just go through the standard sort of Blast Furnace spiel, and then we'll get straight into it. So welcome everyone to Blast Furnace. Just for those that don't know what it's all about, code, meet, and collaborate. So we basically learn how to write some code or play with some hardware, some programmable hardware. We get to network, have a bit of pizza, and collaborate on the stuff we're working on. As always, we thank our sponsors. So we got CISP, the STEM Industry Schools Partnership Program, and Dashworks for giving us the space. And I think everyone knows the bathroom and stuff is in the back there. Fire exits. All right. So tonight we're going to be programming Raspberry Pis. Not just writing code on them, but actually setting our computers up to be proper development machines for Raspberry Pis. Ways that we've, through our own experimentation, have found the easiest to quickly develop and test code on a Raspberry Pi and then build it. But we're going to specifically be doing it with NodeJS. So it's a real web developer's tutorial to Raspberry Pis, and I'll be taking you guys through it. For the next Blast Furnace to be decided yet, we're going to make sure that we can do it again at the makerspace, assuming no further restrictions are put in place, and then that'll sort of affect which presenters we get. But keep a lookout on the meetup page and the Blast Furnace page to see what the next event will be. As always, if you want to help support, you can buy a shirt off us for $10, and the money from that goes straight back into funding the pizza and the drinks for the events. These are our social media handles, and they are the passwords. So make sure you get the passwords, because we're going to plumb them into the Pis so they can connect to the Wi-Fi. Otherwise, let's get straight into it, I reckon. So firstly, to get started, you should be able to find the repo, blastfurnace.com.au. Should be under the View Lesson button if you can get the page to load. So if you can, if you get to the Blast Furnace page and get View Lesson, you'll get to the repo. And then there's a button on there. So I've set this repo up as a template, so you can hit Use Template, and it will effectively fork the repo, I guess, into your own. Name it whatever you want it to be. Or you can just download and use this one, whatever you want. But if you plan on, using Node.js to code on Pi, I'd suggest using it as a template, put in the repo in your own GitHub, and that way you'll be able to reuse it, modify it. So what you'll see when you get this repo is the README is quite comprehensive. So I put a lot of tonight's instructions into that. So effectively what we're going to be doing is setting up the Pi initially. Now, for those of you that want to run through with a normal Raspberry Pi, you'll see setting up your Raspberry Pi and the instructions there. So a bit of downloading, so feel free to kick that off. You'll need a way to put an image on the Raspberry Pi, and I've got Balena Etcher there if you want to try that one. You also need the .py image for Raspberry Pi, and it comes as a like a 7Z archived folder, so you may need 7-zip to unarchive it. So I'll put a link for that there as well. If you want to try the simulated mode, you're going to need VirtualBox and .pi VirtualBox image as well. Now I have my own Raspberry Pi, so I'm going to be doing the real deal.
But it says Oathmate, we're in Australia.
Ballina Etcher here. But the download install process for that's very straightforward. Just grab and follow this link here, download and install Ballina Etcher. And it should detect your operating system. And this button down here, once the kicks through, will just be hopefully a download button for your operating system. So it's detected mine's Windows. We'll also grab the latest .pi image, so I'll get that while we're waiting. So if we scroll to get to the download section of .pi, Raspberry Pi, and the link just comes up just there for Raspberry Pi download image. And you should get, at the moment, .pi, rpi, armv6 buster.7z. Because what we're also going to do if you don't have it is we'll go through the Pi setup in a second, but if we want to kick another download off, we also want VS Code with the SSH plugin. So you can, again, install that. Both links here. I think I have it cooking already. So what I will do is I'm going to, okay, I got the repo cloned, the latest and greatest. All right, so you should have downloaded the .pi image. So you will have to extract that. So for me, it's just a matter of right-clicking, extract all 7-zip. So I've got that extracted. Now you want to run Ballina Etcher. So if it installed correctly, it should either be a desktop icon on the desktop or it'll be in the start menu. And you'll get a screen like this. So the first thing you want to do is select your image, in this case .pi, and then select your target. You should have an SD card selected.
Just been awarded more airtime.
All right, thank you very much for the extra airtime. Here we go. Okay, so I have a .pi, my SD card's been detected, I'll select it. It does give you a warning because I'm using a 64 gig, and if you use a 64 gig SD card or larger, it will say that maybe this is not the removable memory you actually wanted to use, but in this case, I'm pretty sure it is. So continue. On Windows, you'll have to allow it to access, basically disk part is what it's accessing underneath the covers. Ballina Etcher has a special version of disk part. And it'll flash away and it won't take long. All right, so yeah, for anyone that's just jumped on board, basically what we're doing is using Ballina Etcher to flash the Raspberry Pi's SD card with .pi. So if anyone is wondering what tutorial we're following along with, you can go to blastfurnace.com.au and hit view lesson, and you'll get straight to the GitHub repo. And the README is basically what we're following. There's steps in that. So that's successfully flashed. Flash is complete. Could flash another if we wanted, but we don't need to. So what we're going to do now is actually take the SD card out and then plug it back into the computer. So the computer picks up the drive. I only do this because on some computers it doesn't, once it's been flashed, it doesn't come back on straight away. you have to unplug it and replug it back in. So once you open this, Pi, to basically get your Raspberry Pi up and running, especially if we're going to run headless, which is what we will do. For this demo here, we'll be using Raspberry Pi 4s, but we also have Raspberry Pi 0s, and is yours a 3, Darcy, as well there? Yeah, so we're covering all bases. This will work with any of the Raspberry Pi types. So I don't know if you guys can see that, if it's clear, but effectively, Pi, when you open the SD card you just flashed, it has this really cool .pi.txt where we can do some configuring. So if you actually open this up, you'll see a whole bunch of settings that you can configure straight out of the box. So this is really good for headless setup. So like straight away, one of the ones I like to change is the auto setup keyboard layout. So I'm going to change mine to US. And you can change the time zone here. So we're going to be operating in Australia. Sydney is one of the time zones. Now, also what we're going to do is enable the Wi-Fi. This is the most important one. So we're going to set up Wi-Fi enabled to 1. And don't know if this is going to help us or not, but I changed the host name to something unique for your device. So I'm going to call mine CamsPi. They're pretty much the stock standard ones I change before I get the Raspberry Pi going. There's a heap in here. If you want to have a look, you can set up a heap of different things. You can set up your Ethernet to be static. You can disable your Wi-Fi and just run off Ethernet if you wanted to. How it logs in when it boots, when your Raspberry Pi boots. So there's this really cool setting. I'll see if I can find it here. Login, auto start target index. So you can actually get this to start up using these settings here. You can actually get this to start up with root being logged in or whatever user you want being logged in straight out the gates. But that's what we want to change there right now. And then what we're going to do is save that, close it, and open this Pi Wi-Fi text. In here is where we want to set the SSID for our current site, and that is, if I look it up, dash guess for me. Different codes for different Pis. I'm not 100% sure what you mean by codes there, but this is fairly generic. This image will work for any Pi, and you just configure it. These are all user configurations. Yeah, if you want to see the screen, we actually got it running. Like we've got a proper a screen stream to YouTube. And we'll get the link in the comments there. So what we're doing dash guest. No, we want to put that is our SSID. So put that in there, and then the key. What was that key for dash guest? Is that right? All right, I'll capitalize it just to be safe. All right, so now we should be right. So all we need to do now is actually disconnect the Pi, disconnect the SD card, plug it into the Pi, power the Pi up, give it a second or two, and it should connect to our Wi-Fi network. If you're following at home, you can also just Ethernet straight into your own router. You don't necessarily need the Wi-Fi, but we are going to be running on Wi-Fi here. And mine's booting up. So the trick will be figuring out what your IP address is for your Pi. I don't know if the host name will come up first setup. That's the thing I'm worried about, because we set unique host names, but I think on first setup, it might be the default .pi one. So if we figure out between us which IP, we'll just all connect to a different one and configure one of them that we connect to, right? Well, actually, we've all got a different Raspberry Pi, so if we can check the Pi type, we should be sweet. So if I go back, so what we'll do is we'll try and see if we can figure out if they're connected to the network. I use Fing, and there is Fing desktop out now. So let's have a look and see what we can find. Maybe it won't let me because of the network type. So we can't scan this guest network that we're on. So we're using basically all the Raspberry Pis, and we're basically going to get it set your computer up to program Raspberry Pis with Node.js. That's what we're getting to. We've got a few guys here in the room following along, and right now we're just trying to get everyone's Pis connected and set up. So what I might do is, while we're working through that, is if you scroll up, there are links to both the live stream and the GitHub repo with the README that we're following along with. And what I'll do is I'll also take you through the simulated Raspberry Pi setup as well. So on the README, you'll see there's a download for VirtualBox. And I'm running on Windows, so I'm going to use the Windows hosts. Hopefully for those that they're jumping on the Reddit stream there, that we can't stream this computer screen through Reddit, but what we can do is you can get onto our YouTube live stream. Right.
But that also means you won't be able to see his webcam face.
Yeah. Yeah.
So you'll have to make the difficult decision of learning useful things or seeing his face.
And looking at me, that's right. Tough choices. We've all got to make sacrifices, I guess.
Or if it's fun, if you have 2 windows.
Or you could open 2 windows. Have your cake and eat it too. So I've got VirtualBox installed now. I'm just going to run that up. So that's running, and what I'm going to do is just go back to my repo here, and we'll get the Diet Pi actually very conveniently has a VirtualBox image for it. So if we click on that and download, so this is a way to basically, if you don't have a Raspberry Pi on you, but you still want to test your development against the Raspberry Pi OS or whatever OS you want to run on the Raspberry Pi. In our case, we're going to use Diet Pi because we want something lightweight that's going to run not too much bloatware coming with it. VirtualBox and the Diet Pi VirtualBox image is a great way to do it. I will say the downside to that is that it isn't an ARM architecture. It is going to use your architecture of the PC that's running VirtualBox. So ours is going to be an x86 architecture. Unfortunately, it's not going to allow you to build for ARM, but it will allow you to basically run through the process, still test things like NodeJS, which is going to run across things quite well. You're only going to hit problems where we're trying to test things that are native to the Raspberry Pi, like IO-based libraries, trying to toggle IO pins or something like that. It's obviously not going to work on your Windows PC in VirtualBox. So we've extracted that VirtualBox image now. To set this up, double click on it, import all the defaults, and it basically gets your Pi virtual computer running. What we can do is I'm going to configure mine to match the specs of the Raspberry Pi 4. So I'm going to change the RAM to 4 gigabytes or 4096 megabytes. And CPUs, let's have a look here. I want 4 CPUs as well. Processor, I'm going to give it 4 cores, just like the Raspberry Pi 4. So I'm running my 4 gigabyte, 4 quad core Raspberry Pi simulation. So you hit start and it'll run it up. For you guys, so we can't access it through this network. You got a what? Oh, access point booting up. So you guys are going to connect to that guy. So, okay, so if we want to do that, the easiest way to correct the Wi-Fi password, reflash it. Just pull the SD card out, reflash it, change the Wi-Fi SSID and key to Eric's router, and we'll try and use that. So on the VirtualBox, we're going to go into the Pi setup. And so while you guys are waiting, what we'll do is, if you guys sort of take notes, there's not too many custom configurations when you do the Pi. It's pretty straightforward. It's basically just clicking through. Default passwords, Pi. It comes with the image. All right.
The comment was that he thought it was Goku's hair. We're doing a bit of smoking here. Thinks you can speak Finnish.
Not fluently.
I'm giving you the translation.
Oh, look at that. I can see my Cam Pi on this network now.
He just called you a devil.
The devil. Don't know about that. All right. So I've managed to use Fing to finally get access to my Raspberry Pi. So there's the address, 192.168.1.89. Okay. So it's a start. So now we're going to SSH into the Raspberry Pi. So what we're going to do to use that though is we're going to use VS Code. So if you're following along with the GitHub repo, set up your dev machine. You want to install VS Code and install the SSH plugin. There are a couple of ways you can SSH in actually to a Raspberry Pi. If you've got Windows Linux subsystem, Windows subsystem for Linux, you can actually do that as well. Or PuTTY is the other option. I don't know which one I want to do first. So for Mac and Linux users, you can just open up a terminal and you'll be able to go. So for Mac and Linux users, it'll literally be a matter of opening up a terminal like this and going SSH Pi at, sorry, we're going to go in as root. And then you just want to enter your IP address for your Raspberry Pi. I'm going to do a demonstration.
Extended time.
Oh yes, extended time. Thank you very much for the extended time. And for Windows users, the easiest way to do it is using PuTTY. So I'll download PuTTY for the demonstration of Windows users because it is more difficult. However, if you've got Windows Linux subsystem on your Windows machine, I suggest booting up into that and using that for your SSH. So let's open up Putty, install that. Where to put it?
Extended time.
Excellent. Thank you very much for the extended time. Okay, we're going to do SSH, and we're going to go 192.168.1.89 was our IP address, port 2022, and I'll just call it RPi for now. Save. Okay, let's see how we go. Yes. So we're going to log in as root, and the default password is dietpi. First time setup.
Devin come actually from a moderator.
Oh, really? I'm actually now intrigued to try the built-in. What, with PowerShell or command line or both?
Time extended.
Command prompt. Okay. Is it just SSH? Damn, I spend so much time in the Linux space that yeah, I'm not up to date on.
Windows is slowly rolling out the next virtual machine thing. I haven't really used much of it.
I'm gonna run it as that. I actually think I've seen the issue with this before, maybe. Try run as admin. SSH. Yeah, it's because it's got this weird pathing thing happening. Yeah, I got Putty running now. It's good enough, but yeah, I have to look into the built-in SSH tools for sure. Thanks for the comment. All right, so this will take a little bit to set up, so we'll run through and do some packages and some updates and things. So that's running along smoothly. And this is just the first time setup thing for the dietpi. So it basically runs through updates, gets packages, and then we're going to add some software that we need that are critical for development. It shouldn't take much longer from here, and then I can show you the optimized settings. One of the main ones, as I said, was make sure we've got Git on here. I mentioned Build Essentials and Python, and we're also going to install Node Version Manager rather than just Node. And the reason being is Node Version Manager allows you to switch the version of Node.js that you're running, which I find really useful because often, especially when you're building some of these native packages, they won't have support maybe for the latest, or they'll only have support up to a certain level. So being able to just switch really quickly is really convenient. So this is up to your choice whether you want to help dietpi by uploading your data or not. I like to help them out. Send the survey data, and what's going to happen now is we're going to begin the setup. This is the first time setup. You only have to do this once, and then the Raspberry Pi will just work after this. So I'm going to set up a global password. And I'm going to set it up for everything. All right. Question here about serial. We particularly don't care about it, at least for this tutorial. If you know what you're doing, you might want to turn it on, but realistically, just the default cancel is fine. All right. So here we are now. So now we're going to just add some optimized software. One cool feature it does have, the Diet Pi config does have, is built into it, you can enable a Wi-Fi hotspot. That is actually really convenient if you got the Raspberry Pi hooked into Ethernet and then you just want to actually connect directly to it with your phone, or if you just got it as a device that's not hooked into any internet at all and you're just running code on it that's serving up like an Angular app or something, you can then just have that out in the wild and just connect to it with your Wi-Fi hotspot and then interact with your device and your code through your own UI. So the Wi-Fi hotspot's really cool, and that is in the software optimized list. So we hit OK on that. You actually see you can go down. There's a heap of optimized software here for Diet Pi. You actually will recognize some of them as you read through. No Machine and Real VNC for that remote login. You got torrent engines. You've got.
Speaking of time engines, time extended.
Time extended, yes. Thank you very much.
For 4 minutes. Damn, it's big.
So yeah, there's a lot of options here. Connection to my Pi is starting to lag up, which means there's a lot of people on this network now. So we're going to go back. Definitely have a look through the software optimized list and see what you can configure Raspberry Pi with using Diet Pi. Highly recommend. Now we're going to do the additional software is what's important. So what we're going to install is, let's go all the way down to, we definitely want Build Essentials and we definitely want a Git client. Right now they're pretty much the two. You will notice that NodeJS is here, but like I said, we don't want to install NodeJS, we're going to install Node Version Manager or NVM, which will be better for us to allow us to switch between versions. So there is really only two. That's literally the only two settings I really change. And then you hit enter for install and OK to begin. So now the Raspberry Pi is going to be set up with our basically bare essentials, and it will reboot in a second, but it's also where they're going to come back in and add just a couple more bits of software. And if you're looking at the GitHub, you can move ahead if you want, or if you just come online, you can go backwards. It's basically in the final steps of completing now, and then we'll be able to reboot. And then what we'll do is when we log back in, we'll do it through VS Code. We'll get the SSH working on VS Code. This is when it's going to be. This is the cool part. The built-in plugin for VS Code, the SSH remote plugin. That's the really powerful part of developing with the Raspberry Pi. It allows you to work on your development machine, but when you're running the code and typing the code, everything's happening on the Raspberry Pi, and it's what makes testing it, writing it, deploying it fast. All right, we're up to the reboot. Rebooting now. Dropped out my connection, which is fine. Hopefully, thank you very much for the time extension.
Yeah.
Raspberry Pi is rebooting. We'll give it a second. So we should be able to connect to this Pi now. I'm going to take you through the SSH. So if you haven't already, you can install the remote SSH plugin. All right, so we've got VS Code running. We've got VS. If you don't already have it, you go into the extensions and you should just be able to type SSH. First thing that comes up, remote SSH install. I've already got it installed, but that's all you should have to do. Let it install, reboot VS Code, whatever it needs to do. Then you get this little icon down here on the left-hand side, our Remote Explorer. What we're going to do is we're going to add a target. So we're going to add new. And here you want to type in basically SSH and then your user, which we're going to use as root, and then the IP address of our Raspberry Pi, which is going to be 192.168.1.89. So we go confirm, enter, that's saved that now, and you see it comes up in our little SSH target list. So what we can do is hit the plus folder, and it's going to try and connect to the Raspberry Pi. It'll ask us what platform. We're going to go Linux. Yep, we've got to confirm our fingerprint and then put in our global password that we've set. Now SSH is being set up on the Raspberry Pi. You can open up the terminal, debug console, output.
Oh, the stream just caught up to the point. Cam's just flexing.
So the setup for the SSH, first time you get it running on a new Raspberry Pi image, it does take a little bit because it's doing things. If we look at the details here, it's doing some downloads and set some stuff up on the Raspberry Pi. But after that, it's actually quite fast. Just the first time setup for the remote SSH. So it's downloading something on the Raspberry Pi through the wireless and setting up. Like I said, this will be a one-time setup, and then the SSH is going to be quite fast from here on out. And what it'll allow us to do is this terminal window will look just like the Raspberry Pi console. And when we open up File Explorer, what we're going to see is just looks like a normal VS Code, directory structure, but it'll be on the Raspberry Pi, so it'll be the Raspberry Pi's directory structure. So while we're waiting for that, this repo, for those of you that are already familiar with NodeJS, basically you can actually pull and run this repo on your computer as well. So it's not Raspberry Pi specific code by any means. You can pull it, basically npm install, and then I've got some good package tips down the bottom here. So npm start will just run the main TS. It'll serve up what the project effectively is a bunch of Node.js code with for Express. So there's an Express server on there that's going to serve up a pre-built Angular app that we have as part of the repo. But we also have a comms class. I'll note this all in TypeScript as well. So it builds the TypeScript to JS and then runs the JS code. What will happen is it'll serve up the Angular app. It'll run a WebSocket comms class. That's going to communicate to the Angular app that's also got WebSockets. So that's how we're talking from the Node.js sort of back-end code, I guess you could say, to the front-end Angular app via WebSockets. The WebSocket app is a very basic app. It's basically got a command box and the send button, and you can just send commands back down. So it's sort of written as an example of how to create an Angular app that then talks to your Node.js code that's running. For anyone that's just joined us, we're basically SSHing into a Raspberry Pi with the VS Code SSH remote. It looks like we're in a perpetual state of network death. So I'm going to reboot the Raspberry Pi. So just unplugged and re-plugged in the Raspberry Pi. While I'm here though, let's have a look. I'm going to open up the code base and just show you guys what is in this code base, because this will run just on your Windows PC as well. So this is the demo project that I got. It's sort of a good template for using Raspberry Pi. Basically, what we have here is what I call the controller code, or the code that's it's all the code's running on the Raspberry Pi, but this is code that's, I guess, specifically staying and working with the Raspberry Pi. And what we also have in the build folder here is a dist folder, which is an Angular app. So whilst it's being served from the Raspberry Pi, the usage and interaction is going to be on the device that that is connected to the Raspberry Pi. So the Raspberry Pi is going to serve this app up to multiple clients potentially. So we're using an Express.js server to do that. So if we have a quick look at the code, our main is very, very simple. We effectively import our two classes that were built. I will note this is in TypeScript as well. And then we instantiate the classes. So comms, which is going to be our WebSocket communications. This is how we're going to talk to our front-end UI, our Angular app, and the Express server, which is actually going to serve the app. So the first thing I'm going to do now I'm in the project is just do a npm install, hopefully. So here's the project. We've done an npm install. This is the main, like I said, only has two components, the express class and the comms class. Comms class is super straightforward. It's a WebSocket based class and effectively facilitates devices connecting to this WebSocket server and handling messages that come from it. So to give you an overview, the app that I'll serve up in a second basically is an Angular app. WebSocket's running to and from this main Node.js code, and it's very basic. When a device connects, it sends a little message back to Angular to say connection successful, and then as the device sends messages to this WebSocket server, effectively uses this message on event and console logs the message that gets received, and then jams the command into this switch statement. So right now we only have one command, which is echo. So if the command is echo, effectively the code just says, all right, just send that message straight back to Angular. And if it doesn't recognize the command, it says bad command.
5 minutes remaining.
So we've got 5 minutes remaining on the Reddit feed here. So if you want to keep following us along, check out the YouTube. Check out our YouTube link, and we've also got a Twitch stream. Link should be in the chat here. And the Express server is really, really basic. Literally, all it does is it picks up our folder it picks up our Angular project from the dist folder and serves it. The port that it's going to serve our WebSockets on is 2506, and our Express server initializes with port 1904. So in the package.json, I've got some useful npm scripts here. The first one we need to do is npm start, which is going to build all our TypeScript code and then run the code using Node. So we'll just go npm start. So built and ran. So basically, got the WebSocket running on 2506, and we've got the Node.js being served localhost 1904. So if we actually control click and follow that, you can see this is the Angular app now on the screen that is actually being served.
Time extended 1 minute.
Thank you very much for the time extension. So what we've got here now is the app being served, but the WebSocket communication isn't happening yet. And that's because in this case, it's going to be on localhost, but if you connected to your Raspberry Pi via your device and then tried to connect to this web page, you wouldn't want your WebSockets to connect on localhost. You actually want to connect them on the IP address of the Raspberry Pi. So in this basic UI, I have a connect command. So if you actually type connect and then just put in the IP address, 192, the IP address of the Pi, but in our case, it's going to be, because we're running it on the same machine, it's going to be localhost, and the port, which you can see from the console window, is 2506 here. So if we go back to this app here, connect, we get a message, reply, connection successful, connected to the device. So now what we can actually do is tie the echo command, echo the standard hello world. And if we actually send that, it echoes it back to the Angular app. You can see here, echo hello world. And if we actually look into the console for our Node.js app running here, you actually see it shows you that it received that command, echo, with the data hello world. So now if we actually jump back in here, we can actually put a different command in here, say test, and then test data, any string after that. So this basically, what this input box does is it takes the first word as the command, separated by a space, and then anything after the first space is the data for that message. So if we go send, it actually replies error unknown command test, because we haven't actually defined the command test. You'll see it says it here, receive bad command, command test, and the data was test data. So if we wanted to actually facilitate using that command, we could actually add it here into the comms class. For the Reddit stream, we've got just under a minute left, so just wanted to say thanks everyone for on there for watching, and thank you for the time extensions. If you want to follow us, please jump on the YouTube stream where we've got the screen capture going, and the Twitch stream as well. So, for example, let's just make a quick change to this. So if we click down in our Node.js window and hit Control-C, yes, to stop running the Node.js project. Come back into our comms class. This is under comms class.ts. What we can actually do is just add another case. All right, thanks Reddit guys. Catch you later.
2, 1.
So we can actually jump on here, and so what we can do is do a case for it. Let's say we want to use the test command. So we can do test, and rather than, we can change the command that we're going to send back to Angular to say test received, and let's change the data to successful test message. We can save that. And then we just run npm start again. It'll rebuild and rerun our app. Now, the only thing you'll have to do is when you go back to this, it looks like it's still running well. But in reality, it's actually, the WebSocket's dropped out because we closed our WebSocket server and reopened it. So what we actually do is have to rerun our connect localhost 2506. And now we should be able to test our test command. So test whatever, doesn't matter because we're not doing anything with the data. And we get test received, successful test message. And then if we put in a command we didn't know, we'll get a bad command. So that's a sort of run through of the demo of what the demo app is doing. So one of the cool things we can do, and this works for Raspberry Pi as well. So what we can actually do is run a script here called npm run. We're going to do package Windows. What that's going to do is it's going to build our Node.js code here into a Windows exe, effectively. And it's got the first time it runs, it's got to actually fetch the version of Node.js that you're running with, that it gets packaged up with.
Showcasing skills.
All right, welcome everyone to anyone that's jumping on the stream. We're doing Node.js development on a Raspberry Pi. So basically, what we've done, we've just built the window exe. On this window here, you can see it's finished and it's built it, and in this bin folder is where it puts the built package. So if we actually go reveal in File Explorer, get this nice little exe. So now, if we actually just double click on this exe, allow access, it's serving the UI on localhost 1904. Which is here. So if we actually refresh this now, so now our Angular app is actually talking to the built exe and not the development version of the app. So what we want to do is same as before, connect, still on localhost, so that's fine. 2506, connect, connection successful, and now we can run our echo test. And it echoes back the message hi down here in the bottom. So that's kind of a step through of like and then you can see the console logging here on the window of the exe. So we can Control C to close that. So that's kind of a breakdown. So what we'd be able to do if we had this going on the Raspberry Pi is actually npm run build package dash Linux. So if you check out the package.json here, you'll see the commands that I put in there. And so you got package.linux, which runs the package npm package with the Linux flag. I'm just going to get my network running again. I'm going to retry. Yep, we're going to have issues because it got halfway through the VS Code. Failed to create hard link. File exists. So what we're going to do is I'm going to actually try and kill this. So if I actually, let's go putty, I'll go web SLSR. So if I go SSH root at 192.168.1.89. Yes, my password. I'm going to go remove. Ugh. Whatever that is, that's what's stopping us from VS Code from working. So I'm just going to kill that. I'm going to remove that. All right. So now we're going to reload this window and see what happens. Downloading with wget. Here we go. Kill this SSH. So now we're basically setting up the Raspberry Pi with the VS Code SSH file, hopefully. Basically, you have VS Code running on your computer, but you have this SSH extension hooked in. So when you go to the File Explorer, it's actually the files running. It's actually the files and directories on the Raspberry Pi. And when you're writing the code in your VS Code IDE on your development machine, it's actually being written and saved to the Raspberry Pi in real time. So when you're hitting save and run, it's running on the Raspberry Pi. So it's a really fast way to develop and test code on the Raspberry Pi. Getting my VirtualBox to talk to my network. All right, looks like VS Code has finally gone through. So right now on the screen, you can see I'm SSH'd into 192.168.1.89. Now if I open a folder, you actually see it's just a root folder of the Raspberry Pi. Like I don't have all my Windows folders and options and things. So hit OK. It'll ask me for my password again. Oh, thank you very much for the time extension. So we're here now. We made it. Notice when I open the terminal, it's not the Windows terminal, it's the Raspberry Pi's terminal. And it's running .pi. We can see the temperature of the Pi. We can see the LAN IP, Pi model. We can run Raspberry Pi style commands from here now. And so one of the ones we want to do, app get install Python. Python's installed. Sweet. Now let's set up Node Version Manager on the Raspberry Pi. This is important. you go back to the GitHub repo, pretty basic set of commands here for the Raspberry Pi. So if you go to installing NVM in the README, and then installing on your Raspberry Pi, first we want to clone the NVM project. So just copy that command, paste it in here. Actually, git clone might hate me here because I haven't set my global. It'll hate me when I try and do pushes and pulls, maybe. Remember how to do that.
Time extended.
Yeah, thanks very much for the time extension. Yep, all right. We'll have to set this. You want to set your git config on your Raspberry Pi as well. Oops. Delay in SSH. So I'll set up our global git config because that's going to be important in a second when we start pushing and pulling code. All right. So now we've installed, we've cloned NVM. Great. Now we just want to run these set of commands so we can just use the NVM command. Ugh. If I can do Control C properly, it will be in business. All right. So the only thing is we have to restart the terminal. So what we'll do is we'll just trash it. If you do terminal, new terminal. Now, if we actually test it, we can go nvm -- version. We can see the Node version manager is installed. So now we can actually add whatever version of Node we want. For the purposes of this library, we're just going to use the latest, but you could use any version. And to check what versions are available, is it dash remote? These are all the versions of NodeJS that you could use. And with 12.18 being the latest, so you could go nvm install 12.18.0 if you wanted, or if you want the latest long-term support release, you can just go --lts. Now I'll download and install that. If you go to the repo and have a look, I actually got some tips in there. As well, so the commands you want to use. Matching checksums, we're using the latest. So now if I type node v, you can see we're using 12.18. And if I wanted to, I could install a second version of Node.js, and then by going nvm use and the version number, I can then set what version of Node I'm running everything against. So that's all done. Node's installed, Python's installed. So now we want to get our repo on here. So let's go back here and we're just going to do a git clone. So we'll copy the URL. What we'll actually do, instead of using the command line, we actually use Git's VS Code's built-in tools. So we can view the command palette, git clone, paste our Git repo in there. Yep, I'm going to put it in root, okay. Now this where it may ask me for my Git credentials unless I've already put them in. It may ask you for your GitHub credentials here. So it's just cloning it in, and now I'll say open that workspace. So I open our Node.js project on the Raspberry Pi. So now we're open in our project. So you can actually see the path here is in the Node.js Raspberry Pi project. We'll install our dependencies, npm install. So once we install and run this is where I'll show you something kind of cool will happen. We'll be running the project. The Raspberry Pi will be serving the web page from its IP address. We'll be able to load it up and connect to it from our development machine. And this is where having the Wi-Fi hotspot comes in handy, because you can connect to the Wi-Fi hotspot then on the Raspberry Pi and basically have the Raspberry Pi serve you up neat little UIs, however you make them, whatever front-end framework you want to use, and then interact with the device at the device level using the Node.js code. Likewise, we can run the package just like we did a demo where we packaged it for Windows a second ago. We'll be able to package it for Linux, and it will do a specific ARM build that will work on a Raspberry Pi. So you can actually fully develop the app, package it up, and then just send that to other people to use. The only caveat with package that I've come across is, so 9 out of 10 times when you're writing packages or writing code for Raspberry Pi, you're going to want to use packages that use the I/O. That usually has to have some kind of native build to make it work. When you package up your Node.js app, you'll get the executable file. You'll also need to do an npm install just for the native modules and sort of zip them up with your exe. Otherwise, it'll fail to run. But if you do actually zip it up with your exe, the package, the way that package works is, or PKG works, is it'll actually look for your dependencies in and around where the app is running from. So it's not amazing, but the workaround's not that hard. It's just you have to have the Node modules for any native packages. So that's npm installed. So we should be able to do npm start, which is going to build our TypeScript into JavaScript, and then it's going to run our main.ts, which becomes our main.js. So now it's running. Server for app listening on HTTP localhost 1904. So now what we can do, or theoretically, if we jump into a web browser on our development machine and we actually go 192.168.1.89, 1904 was the port for our Express server, we actually get the Angular app. So this app is now, we're interfacing with it on our development machine, but it's actually being served over the network from the Raspberry Pi. So the only caveat now is, like before, we were connecting our WebSocket comms channel using localhost. Now we're going to have to use our, we're actually going to have to use the IP address. So we can go connect. We're going to have to go 192.168.1.89, 2506, send, and now we've got a successfully connected device. So now we've got our dev machine talking via WebSockets to the terminal running on the Raspberry Pi over the network, and run our hello world. Successful. And if we actually go back to our SSH window, you can see the commands are coming through on the Raspberry Pi. So that is all being served up now. Basically, to finish it, we can basically do our npm run package Linux. So this is interesting. So what it's done here is it's looked for, it's going to package it all up with the ARM version of Node.js, which it couldn't find. So now it's going to download the source and build it. And then what this will allow us to do is to have a built app that just runs. So we don't, if we wanted to share this with someone or have this run on someone else's Raspberry Pi, they don't need to pull the whole project and have all the Node modules. It's just going to be this nice little built executable, and effectively it's a lot lighter weight. All right, so I don't think there's much more for us to do, really.
I'm gonna erase this.
But yeah, as far as the Node.js stuff, I sort of got through it now. It looks like I was on the verge of building, and then I'd say a network error or something. But that's what we're battling with all night. Definitely the GitHub repo. So I actually want to explain the real reason we're here, which was to develop with Node.js on Raspberry Pi. But yeah, we just sort of wrapped it up. But if you go through the comments, you'll see the links.
There's a bot on YouTube.
Miguel started at noon. You guys.
Oh, nice. Jeez. That's a hell of a session.
But yeah, to the Godfather. Yeah, it's we were doing basically setting up your computer to develop using Node.js on a Raspberry Pi, and yeah, we just sort of finished up. There's the GitHub repo link, and we also have a YouTube stream at the moment. We're going to turn that off soon.
We've got like 16 minutes, man. So answer that one.
Yeah, so that's right. So we're running Node.js on the Raspberry Pi, and not only running it, but building it into an executable that can be distributed to other Raspberry Pis that don't necessarily have Node.js on them. So, but the more important part was setting up the computer, your desktop machine as a development environment for it, and using VS Code and its SSH extension to connect to the Raspberry Pi. So you're coding on the computer, but it's everything's running on the Raspberry Pi. So you sort of get the best of both worlds. And yeah, the Node.js package PKG allows you to build that up into a nice little ARM executable. And you can just then get that running on all your Raspberry Pis. That's sort of what we went through. Hopefully we get a bit of, next month we might do a bit of actual UI development with Angular at the front end. So with this Node.js repo that we got here, it has an Angular app built into it, just for testing purposes. But you can, what you can do is build that app yourself, obviously, and we're going to take you through that. Any last mentions? Yeah, if you want to see just a little project we've been working on, cipherlinks.com. Always up to date online resume for programmers. Basically, jump on, connect all your third-party platforms, and the site generates a resume for you that you can share with recruiters or whoever. Free to use. We're just trying to get that right. So if anyone can jump on and give us feedback, that'd be great. And yeah, with regards to the blast furnace, it'll be in a month's time. So second Thursday of July, we'll be back again. Alan will be keeping his seat warm doing the makerspace on the Reddits.
Yeah, on the Reddits, on the Twitch, on the YouTube.
All right.
Links everywhere.
No worries. Thanks very much for everyone's time, minutes. We'll catch you next time.